Your learning intention for today is I know how to multiply fractions with whole numbers. Your success criteria is I know how to turn whole numbers into top-heavy fractions or improper fractions, that's another name for it, so that I can multiply the numerators and denominators. Okay, before we jump into the lesson, let's discuss denominators. Now, when you're adding or subtracting fractions, does your denominator need to be the same? I hope you know this by now, but if you don't worry, I'll remind you. Yes, whenever you're adding or subtracting fractions, your denominators must be the same. Why is this? Well, you can't add half-size pieces, which are, pretty chunky, because it's just, something cut in half. You can't add that with a little tenth size piece, something that's sliced so small. They aren't the same unit. You need to turn them into the same unit. In other words, have them be the same denominator. Now, when you are multiplying fractions, okay, which is what we are going to be doing today, does your denominator need to be the same? The answer is no. I will repeat. When you are multiplying fractions, your denominator does not need to be the same. Now, you could do this, change your denominators to be the same, but it would just be more work for you and would be unnecessary. Okay, let's jump into some examples. I'm going to show you a pretty simple example and then a little bit more of a complex example where we're going to need to do some decomposing. And then at the very end, I'm going to be showing you I'm going to be showing you the fast, easy arithmetic version to it without pictures. Now, do not skip to this part of looking to the arithmetic procedure way, because I want you to really internalize and conceptualize looking at the pictures and understanding what is happening behind these numbers. Okay, let's jump into it. Enough of me talking. Let's start off with something simple. 1/2 times 5. So you can see I've drawn each block, I've cut them in half, and I've drawn 5 of them. Grab my marker. So 1/2 times 5. Pretty simple and easy to draw. For your video response problem, I'm gonna have you draw something like this. So 1/2 and 1/2, if we were to combine these, that would be 1 whole. And then these two I can also combine into 1 whole. Now I don't have anything over here to combine because I just have 5, so now I'm just left with this little half-size piece. Now we can count up our wholes and our half-size pieces. Now we have 1, 2 wholes, and 1/2. Pretty simple, right? Okay, let's go to a more complex problem that I've drawn here for you. And this time I have 2/3 times 4. So as you can see, I have this circle. It's cut up into 3 equal pieces. 2/3 of them, 2/3 of them shaded in. Now I can't do this thing where I combine 2 of them because this isn't a half. So can't do that. Instead, I'm going to count my shaded pieces. 1, 2, 3, 4, 5, 6, 7, 8. Looks like I have 8 shaded in pieces. Now the denominator tells us, remember, what does it tell us? What kind of pieces? What kind of pieces? Well, tell me, what kind of pieces do we have? Thirds. We have 8 thirds. Ta-da! Now we have this answer over here in the corner. 8 thirds. This is a top-heavy fraction, as you can see, because the top is a larger number than the bottom. And this is not necessarily incorrect. This is fine just the way it is right now. But in your practice problem, I want you to practice decomposing for this part. So 8/3. I know that 3/3 can go into it. So that's one whole right here. And then I'm left with, what's 8 minus 3? 5/3. Can I decompose some more? Yes. So I'll do 3/3 over here. Take that out, which equals 1. And then I'm left with 2/3. Now I don't need to decompose anymore, and I can count up my wholes. 1, 2, 2, and 2/3 right there. Sorry, that was drawn kind of poorly for you. Ta-da! Okay, now that I've shown you with pictures, let's go into the arithmetic. So I'm going to copy these problems on the back. I did 1/2 times 5. And 2/3 times 4. Okay, now I'm going to show you without pictures. 1/2 times 5. Well, as you can see, we have 5. How can we change 5 into a top-heavy fraction? Well, I will show you. 1/2 times, 1/2 times 5 is the same as 1/2 times 5 over 1. Because how many times does 1 go into 5? 5 times. So 5 and 5 over 1 are basically the same thing. Now I can multiply straight across. What's 1 times 5? 5. And what is 2 times 1? 2. So now I have 5 halves. If I were to decompose this, I would get 2 1/2. Just like that. Okay, same thing over here. I'm gonna write 2/3. Sorry, the lighting. I'm gonna multiply it by 4 changed into a top-heavy fraction, which is basically placing it over 1. 2 times 4 is 8. 3 times 1 is 3. You guys know how to decompose, and we got the answer on the back already. Which is 2 2/3. Those are my 2 answers. Okay, time for your practice problems. Here are your practice problems. Hold on, let me get the lighting right. I want you to do 1/2 times 8, and I want you to show me using the pictures to solve that one. And then over here, 3/4 times 6, I've actually already drawn this out for you, but I want you to show me by turning this 6 into an improper or top-heavy fraction. You can rewind this video to see how I did that. But the picture is already drawn for you for this one, and this one I want you to show me, draw your own picture, basically. Okay, have fun with it, guys. You can pause this video or look at the description bar to see the practice problems.